Hey guys, welcome back to my channel. Hope you are doing extremely well. And this is your very own Mars coder this side. So today's problem is count the number of possible triangles. It is a very good problem. Even I had to solve it for some times to get the answer. So please pay attention, right? Okay. It says that you have an array which are the sides of triangle. That is, this is a side of length 4, side of length 6, side of length 3, side of length 7. That is a of I equals to side of length I. Side of length I. Okay. Now from these sides you have to construct as many triangles as possible, right? Now how to check if three sides, obviously this triangle contains three sides. Three sides. Let us say these sides are A, B, C, right? Now how to confirm whether A, B, C form a valid triangle or not? Form a valid triangle or not? Valid triangle, right? How to form. So there is something known as triangle inequality. You must have studied it at school level. Triangle inequality, which says that the sum of two sides should be greater than third side. That means A plus B should be greater than C, A plus C should be greater than B, and B plus C should be greater than A. If these three conditions hold, that means you have a valid triangle. Valid triangle. I hope I am clear, right? Sum of any two sides, A plus B, B plus C, or A plus C should be greater than the third side, the remaining side. Now, how to solve this particular problem, right? How to solve this problem? How to get the number? How to get the number, right? Okay, the 4, 6, 3, 7. I want three sides. I want three sides. From an array, I want three different numbers, three different elements. How we do that? That means I have to form all the triplets of an array, right? Okay, that means if my array is 4, 6, 3, 7, if I have to form all the triplets, what is the brute force approach? The brute force approach says I will go from 0 to n minus 1, n being the size of the array. J will go from I plus 1 to n minus 1. K will go from j plus 1 to n minus 1. Now, your first side, that is A equals to array of I, B equals to array of, sorry, B equals to array of J, and C equals to array of K. Just apply the three inequalities in the if condition. If these three inequalities are holding, then it answer plus plus. That is, your answer will be starting from 0, right? If A plus B greater than C and B plus C greater than A and C plus A greater than B, all of these are true, then answer plus plus, right? After this loop ends, then this loop ends, then this loop ends, return answer. So what have we actually done? We have actually, from these three different loops, we have actually created all the triplets possible, all the triplet possible. Right? I hope I am clear. I hope I am clear. Now, what is the time complexity? Very clear. Three nested loops O of n cube and space O of 1, not using any extra space to keep any data structure, etc. Right? Okay. Is there a better approach possible? So because you're on mass code channel, better approach is possible. Better, right? The size of the array is 4, 6, 3, 7, right? So a better approach says that A plus B greater than C, right? A plus B greater than C. We want this inequality and two others, right? Now, what if we sort the array? Sort the array and consider A, B, C as ordered elements. Ordered elements. What do I mean to say by ordered elements? I say that A equals to array of I, B equals to array of J, C equals to array of K, and I less than j less than k, right? That is A, B, C are occurring 1, 2, 3, right? In the sorted array. In the sorted array. That is after this array is sorted, it looks something like 3, 4, 6, 7, right? And A, B, C. What is the possible pairs? A can be here, B can be here, C can be here, right? But B, A, C is not possible, right? I am only saying A, B, C is possible, right? Now, in the sorted array, what can I do? My approach says that use a loop. How? For I equal to 0 till n minus 1. A equals to array of I, right? So what is happening? This I pointer is giving me first side, giving me first side, right? Okay, that means suppose I want to say my I is lying here, right? Inside it use another loop for j equals to 0 till not 0 sorry I plus 1 I plus 1 till n minus 1, right? And b equals to array of j, right? That is j is giving me second side, right? Now in the brute force we were doing for k equal to for third side, right? We were doing for k equal to and the triangle complexity was going in O of n cube. We cannot repeat that because we want an optimized answer. What I'm trying to say is this array is sorted, right? And we want to hold the inequality that a plus b should be greater than c, right? That means we have to find all the pairs where a plus b is greater than c, right? Now tell me, now tell me if a is this, b is this, a plus b is 7. Is any pair possible with 3, 4? 3, 4 can form any possible pair? I don't think so. I don't think so. Okay, now suppose A is here, B is here, right? A is here, B is here, right? That is I'm saying A is 3, B is 4. That means the sum is 7. Sum is 7. I want all the sides. I want all the sides where the side length is 7, less than 7. That is the case. That is the case. All the sides occurring after J, occurring after J where a plus b is greater than side length. Can you see that if I want this inequality, right? That means if I find, let me write down. If I find last value where a plus b is greater than side length, I can just add the number of data points inside it. What do I mean to say? See, 3, 4. Let's say it is a 5 also here. 6, 7. Right? Let's say it is a 3.5 here as well. Okay? Just for the better understanding. A is here. B is here. For I equal to 0 till n minus 1. J goes from I plus 1 till n minus 1. These were the loops, right? From this particular loop, these two configurations, this configuration occur that A is come at 3 and B is come at 4. What is the sum we require? What is the sum of a plus b? A plus b equals to 7. Now we want all the sides. We want all the sides which is less than 7. Only then the triangle inequality will help. But we are taking c from here only. Why? Why? Because the pair of 3, 3.5, 4 was already formed when a was equals to 3 and b was equals to 3.5. Because if this is a probable configuration, then this also must have been a probable configuration in the past. So all the pairs with these two elements as A and B have been formed. So we will be taking C only from this domain, right? Only from this domain. That is, we need to find the last element. We need to find the last element whose side length is less than 7. That is 6. That is 6. Now, this is formed. This is formed. Like A is done, B is done. A is done, B is done. We find C that C can occur here at last. How many triangles can be formed? A triangle can be formed with this. A triangle can be formed with this. That is 2. That is in the indexing of 0, 1, 2, 3, 4, 5. When my C lies here, my B lies at 2, my answer will be incremented by 4 minus 2. That is C minus B. Right? I hope I am clear. How to find this C? Now, because the array is sorted, you can use a binary search, which will give me a complexity of log n, of log n, right? And because I was using n square here only before, my total time complexity becomes O of n square log n, and my space becomes O of 1, right? I hope I'm clear. Let me tell you again what we are doing. Let me tell you again what we are doing. The array is 3, 3.5, 4, 5, 6, 7, right? Done. Now, what will I do? I will say I am going from 0 to n minus 1. This is my first side, right? J is going from 0 to n minus, sorry, I plus 1 to n minus 1. This is my second side. This will give me all the first and second side. Now, I'll say int low equals to j plus 1 and high equals to n minus 1. Now find the side which is occurring at last. That is int c, int k, I can say int k is right now equals to minus 1. While my low is less than high, less than equals to high also you can say, mid equals to low plus high by 2, right? If a of mid, that is array of mid, is less than, let's suppose a of I plus a of j, right? If it is less than the sum, then k equals to mid. Simple, we have to shift to the last. Like it is particularly finding the last element. Finding last element using binary search. I hope you have all done that. Last element using binary search. It was in the POTD section itself some days ago. K equals to mid, that k is shifting towards the last, and because we have found something, low equals to mid plus 1, because we need to find the last, so we will shift our element to the right to check for the right part also, right? Else high equals to mid minus 1. Now as soon as this while loop finishes, you will say answer plus equals to, you need to find the answer. First you will check if it is k is not equals to minus 1. If it is not equals to minus 1, then answer plus equals to k minus j, right? And you will shut the inner loop, shut the outer loop, return answer. Time complexity of n square log n and space complexity of 1. I hope I am very clear, right? What have we done? Instead of finding the third element using what do we say, using the particular loop, using a triplet loop, using a brute force loop, we have done this using binary search. But what if I say this is still not optimized? This is still not optimized. Yes, for you guys, I have some of a better optimized solution. So the last and the final optimized. So please pay attention, guys. I had spent so many time on binary search because this is important to understand why will this work. Okay, 3, 3.5, 4, 5, 6, 7. Okay, now this is a sorted array. Our first thing is to sort the array, right? I want a sorted array. Now, my approach says, like, I have a question from you guys. Can I use two pointer? Can I use two pointer? Is this problem somehow similar to three sum? Yes, it can be. How? In three sum, what do? We use a outer loop and then two pointers. Let us do something like that. right? This array is sorted. This array is sorted. Obviously, the largest slide will be on the rightmost side. Largest side on the rightmost side, right? That means if I choose the largest side, this is the largest side possible. This is the ever most largest side possible. Let us do that. I will put my C here. That is for C going from n minus 1 till 0. First side is fixed. This is third side. Third side, right? I am fixing third side here. Now, first two sides, that is A and B, can be anywhere from this 3 till this 6. It cannot pass 7. It cannot pass 7. I'm choosing C as the largest side. It cannot pass 7, right? Now, what will I do? I will say, okay, A will go from 0, B will go from C minus 1. Or let's say C is at index K, A, it is I going from 0, B going from K minus 1. This is J, right? For better clarity, C is the side length, C is the length, and K is the index, right? This is also K. Now, obviously 2 pointer. What is the basic template? While I less than J, that is they don't pass each other for uniqueness, etc. Now, if A of I plus A of J, now what will happen if this sum for a valid thing? I want this sum, that is A of I plus A of J, should be greater than A of K. That is A, B, C. A plus B should be greater than C. This is a valid condition. That is, for this condition, I need to increment my answer, or that is, I can say change my answer. My answer will be affected here for this condition, right? So, what do I have to write in this if block? Let me see. What I'm trying to say is A is here, B is here. A is lying here, B is lying here. 3 plus 6 is greater than 7. Yes, 9 is greater than 7 if condition is getting followed. Now now tell me, because this array is sorted, because this particular array is sorted, can I say if 3 plus 6 is giving me greater than 7, then 3.5 and 6 will also give me greater than 7. 4 plus 6 can also give me greater than 7. 5 plus 6 will also give me greater than 7. What do I mean to say? If I will increase this element, the sum, like sum is A plus B, right? This is my sum, right? This sum has to be greater than C, right? So what I'm trying to say, A plus K plus B is also greater than C. K is or X. If I add any positive thing to the left hand side, it will still be greater than X. That means if I'm increasing A, the sum is also greater than C. Sum will still remain greater than C. So pairs are valid. That is 3 can pair with 6, 3.5 can be paired with 6, 4 can be paired with 6, 5 can be paired with 6. All of them are valid pairs, right? So how many of them are valid pairs? Let us see. 0, 1, 2, 3, 4. These are the indexes, right? 3 and 6, 1. 3.5 and 6, 2. 4 and 6, 3. 5 and 6, 4. That means 4 minus 0 is giving me the right configuration. That is 4 minus giving right number. So answer plus equals to j minus I. This is done for the particular configuration. Now to check all the configuration for this particular side, I like 6 is formed all of them. I will check for 5. I will check for 5. That is, I will say right minus minus. That is j minus minus. Right. Now what will happen for j? Right. 5 is here. 3. 5 plus 3 is greater than 7 again. 8 is greater than 7. That means this will also form a valid pair. This will form a valid pair. This will form a valid pair. Right. Now that means right minus minus, right? Okay, this is the if block. Else block, that means this sum was not greater. Now if this sum is not greater, I have to increase it to get a better answer, right? That means left plus plus. This is a particular 3 plus plus technique, right? At last return answer. So I hope you're clear with this, because it is very easy to understand, just to get the idea that how to get the number of answers, right? How to get the number of answers. For this we are using a loop, and for these two sides we are using a two pointer technique. Now O of n is coming from this, n is coming from this. That is O of n square is the time complexity and O of 1 is the space complexity. I hope I am clear with you guys. First we discovered O of n cube approach, followed by O of n square log n, followed by O of n square. Right? This is the most optimal approach. Right? I hope you are clear and excited to write the code with me. Let us move to the coding section. Okay, here is the coding section, guys. But before adding the code, it's my sincere request to you to please subscribe to the channel. It takes a lot of effort to put a great content for you guys. So, int n equals to array dot size first of all, right? And answer equals to 0. Now, for int k going from n minus 1, k greater than equals to 0, and k minus minus, right? Int I will be starting from 0 and j will be starting from k minus 1, while I is less than j, right? If ARR of I plus ARR of j is greater than ARR of k, in that case, valid pair, then answer plus equals to j minus I and j minus minus, else I plus plus. As simple as that. This was all you had to do. Return answer. Try to compile and run it and wait for the output. Okay, there is some problem, guys. There is some problem. Let me see. Okay, so I didn't sort the array. Let me sort it here. Sort array dot begin array dot end. Sorry, guys, classical mistake. Let us try to compare and run it. Okay, so it is running fine for the sample test case. Let us see for the submission as well. Hope it will work fine. It is running. Okay, so getting accepted. So thank you for watching. Hope you liked it, and please make sure to like and subscribe to the channel. Thank you. Have a nice day.